Okay. My name is Danish Iskandar bin Junaidi, alam ID 019091 from DME43C Charlie, and my project for Solidwork is gear pump. Okay. My name is Danish Iskandar bin Junaidi, alam ID 019091 from DME43C Charlie, and my project for Solidwork is gear pump. Okay. So this is my Solidwork project. My Solidwork project is gear pump. Okay. So let's start with parts number 1. So let's take a look. we begin with the sketch. So first, so this is the cover for my gear pump. To do this, to do this shape, I can simply use center point straight line slot. For example, like this. And then simply just put in the dimension. Okay. So the distance between the center of the first semicircle and the second semicircle is 63.5 millimeters. The the big semicircle have the diameter of 132 millimeters, and the radius of the small circle is 15.5 meters. Next, we can next using extrude boss feature. So I can simply put the depth or the diameter and the distance between this edge and this edge 12.5 millimeters. Okay, next. Using the same sketch 1. Now we cut a hole in the inside area right here. At the back. So of the depth of the cut will be 6.25 millimeters. Okay. So this is the back side. This is the back view of my cover. Let's take a look at the fillet. So I fillet the edge for the edge around the front of my cover, and I also fillet the edge of the edge which I use extrude cut, the edge of this hole right here. Let's take a look. So the fillet is 3.75 millimeters. Same goes with the second fillet, also 3.75 millimeters. Let's go to front view. Next is hole. So using hole wizard right here, hole wizard, I simply choose counter bore hole. Let's take a look at the feature. See, our type is being edited. So this is the dimension for my hole. The depth is 100 meters and 100 millimeters, and the bore diameters is 9 millimeters. Okay. So this diameter right here is 9 millimeters. Next is circular pattern. Under linear pattern here we can find circular pattern. circle pattern here, I click 100. No, let's take a look at my circle pattern. So I choose number of instance is 7. 1, 2, 3, 4, 5, 6, 7, and 180 degree. So the pattern only rotates 180 degrees. Using circle pattern, I can simply repeat one hole right here into a pattern. Next is mirror. I simply mirror. I simply mirror the 7 hole at the top using top line as the center line, or the mirroring point. Okay, let's put it back in isometric view. So this is my second part of my gear pump, which is the connector between the two gear. So first, let's take a look at the first sketch. Edit sketch. So I simply construct 2 circles at the top here and 2 circles at the bottom. The small circle has a diameter of 16.25, and the bigger circles have a radius of 11.5. The distance between the two circles The distance between the center of the two circles is 63.5 millimeters. As a sketch. Okay, next. Oh, next, I use the extrude boss feature. So the extrude boss feature allows my sketch to be a 3D. So with a dimension of 3.125 millimeters, you can see here. Let's take a look. So the distance right here will be 3.125 millimeters. Next, using same sketch. Using the same sketch 1, I use extrude boss at the back. So the dimension will be 3.125 millimeters, same as before, but this time it goes backward. Okay. Next, I make a new sketch. Oh, sorry. Still using the same sketch, but now I use the inside circle. So with a dimension of 5.75 millimeters. Okay. I use the inside circle and make it 3D. Next to the cut. This one right here, I use second sketch for this. Let's take a look at the second sketch. So for my second sketch, I simply make a new circle with a diameter of 50 millimeters. So using the new sketch, I next I use the extruded cut features with the depth of 5.75 millimeters. We will cut through and make a hole inside in this circle right here. So this will be the result. And lastly, fillet. For fillet, so for fillet right here, I choose this edge, this edge right here, And same for the bottom circle, this edge and this edge, the base of the circle. So for fillet parameters, I choose symmetric, and for the dimension will be 2.5 millimeters. So this will be the result. This will be my connector in isometric view. Okay, this is my third part of my gear pump. So this is a, a bush with seal right here. This is the seal, and others is the bush. First, let's take a look at the oops. Let's take a look at the first sketch. Okay, so I simply make this edge, this shape right here, and then I make a center line right here. Center line, and the distance between this center line and this line, I put it as 7.5 millimeters. Okay, 7.5 millimeters. So next, after I done the sketch, I simply use features revolve. So the revolve allows me to revolve this shape into a 360 circular pattern. So here direction, blind, angle 360 degree. Axis of revolution, that will be this center line right here. Okay. So next is the bush. Sorry. The next is the seal. Simply using this sketch. Let's take a look at the from bottom view. So I use convert entities right here, and then exit sketch. From the second sketch, I can simply use extruded boss to make this seal right here. Okay. So this is my bush with seal. Okay. Next is the body. This is my body for the gear pump. Let's take a look at my first sketch. Oops. Okay. Again, just using center point straight line slot, I can simply make this pattern right here, and then just put in the smart dimension. Okay. So the inner circle diameter is 78 millimeters, and the outer circle diameters is 120 millimeters. The distance between the center of the first circle and the second circle is 63.5 millimeters. Next, I use the extruded boss feature to make it 3D. I put the dimension will be, or the depth is 64.5 millimeters. So next I use extruded cut using the same sketch that I just do for sketch 1. I can simply use extruded cut to make a hole in the inside circle with the depth of 52 millimeters. Okay. So Next, I make the second sketch. Let's take a look. First, I can make a center line, and then I can make two circle. One circle with the small circle will be 12.5 millimeters in diameter, and the relationship between the first circle and the third circle it it it, it has 3 millimeters gap between them. So the the bigger circles is 6 millimeter bigger than the small circles in diameter. Okay, as it sketch. Let's take the extrude cut. So using extrude cut feature, I simply click the inside circle right here, and direction I put up to next. I put up to next so that it will only cut through. Oh, sorry. Up to next, it will only cut through the next surface. It does not cut through all of the body. Okay. So next, using the same sketch, I use extrude boss with the dimension of 6.25 millimeters, and now I make it reverse. So just now it cuts through. Now from the sketch, I make it into 3D. Just click the outside circle. Alright. So this be my third sketch. Again, starting with my center line, I made two circles. The small circles has 16 millimeters in diameters, and the bigger circles will be 6 millimeters bigger than the small circles in diameter. So I use extrude cut up to next. I make a hole inside the small circle, and then I use extrude boss to make a 3D figure right here on the outside circle. Next will be my fourth sketch. So for my fourth sketch, I simply make one big circle, this big circle with a diameter of 50 millimeters. To make the sketch fully defined, I put the relationship between the center of the circle and the center of my body vertical. Also, I make tangent between my circle and my body. Next is this tangent line right here. I simply use tangent arc to make this tangent line, and it's as it sketch. So now that I've done my sketch, I can use the sketch to extrude boss to make it 3D. Direction blind. So here 30 millimeters depth. Next is a hole. So using hole wizard, I can simply make this hole. Let's take a look at the hole. So the hole is with this spec. It has 10 millimeters in depth. It has 10 millimeters in diameter, 100 millimeters in depth, and 20 millimeters bore diameter. That will be this from this from here to here. All of this will be 20 millimeters. So the diameter of the bigger circle is 20 millimeters. Next, I make this small clearance hole right here. This small clearance hole. Again, I use hole wizard. And the diameter of the hole is 5 millimeters. So the size of the hole is M5. Okay. The depth of the hole 20 millimeters. So here 20 millimeters will be cut through the body. Oops. Okay. Now that I've made one hole. Oh, sorry. Before that, the let's take a look at the correlation between the hole and the body. So correlation that from the hole and the body is the distance between the center of the hole and the center of the body. I simply put it 47.5 millimeters. After that, I choose circular pattern to make this repeating hole. So I just make one hole, and using circular pattern, I can repeat one hole and make it into a pattern. So I choose 7 hole only for 180 degree. So it will only rotate 180 degree. Next, I mirror the 7 hole to make another 7 hole at the bottom. And then I mirror this part right here. Then I also mirror the hole. All of this is using the top plane. All of this is using top plane as the mirroring point. Okay, let's take a look at the back. Sketch. Using convert entities, I can repeat the same figure or the same body, but now I put the distance between the original and the second body 6.25 millimeters. So using the second body, I can then extrude boss it with 12.5 millimeters diameter at 12.5 millimeters depth. Okay. Now let's take a look at sketch 9. So for sketch 9, I make 2 circles with a diameter of 2.28 millimeters, and the distance between the center of these two circles is 63.5 millimeters. Okay, now using the sketch 9, I can use features extrude cut to make a hole at the first to make a hole through the circle to the first circle. And then for the circle at the bottom, I only use extrude cut with a depth of 6.25. So next is fillet. So for my fillet, I choose this section, the hole right here, the the base of the body, and lastly the base of my inlet port and exhaust port. And lastly, I make another final sketch. Using convert entities, I repeat the same pattern and make a new pattern 2.5 millimeters smaller than smaller than the original patterns. So now using extrude cut, I simply put the dimension or the depth is 2.5 millimeters, and it will cut through this face 2.5 millimeters. So this will be the end result. It will cut through right here 2.5 millimeters. So this is the body of my gear pump. Okay, this is my fifth part. This will be the shaft for my main gear pump. For my main gear for the gear pump. Oh, first you start a sketch. Simple circle. Simple circle with a diameter of 1.50 millimeters. Next, using extrude boss feature, simply make it into 3D with a depth of 100 millimeters. Next, make second sketch. Okay, so I made this rectangular shape right here using center rectangle feature. See, center rectangle feature allow me to make a rectangle, and it will automatically have a center line. So I simply put the dimension 5 meters 5 meters width and 45 millimeters length. So I put the relationship a relation I put relation the center of my rectangle and the origin vertical. Also, I put the distance between this edge and the origin 5.75 millimeters. Next, using both extrude boss feature, simply make my sketch into a 3D with a depth of 9.5 millimeters. So third sketch, let's take a look. So this is my third sketch. Using convert entities, I repeat the circular pattern into a new smaller circle pattern, and the circular pattern will have 1 millimeter smaller radius than the bigger circle. So I make one line right here, connecting one line right here, and this line have relation of coincide. As it sketch. Next, I use extrude cut to I use extrude cut and choose this face, just this face right here, to cut through it 10 millimeters. After that, I simply fillet these two edge, also this edge right here, and then I use circular pattern to repeat this to oh, I use circular pattern to repeat this shape, or this this shape into seven similar seven similar pattern. So using circular pattern with 360-degree angle. So it will rotate 360-degree. So it will copies it 7 times. 1, 2, 3, 4, 5, 6, 7. And last is fillet. So last I fillet I fillet all the edges for my rectangle right here. And that is my shaft, my gear. Okay, the sixth part is a simple bush. Let's take a look at the sketch of my simple bush. So the bush start with a simple sketch. I make this shape right here and center line. So this will be my center line. After I done the sketch, I can simply use revolve feature and make it revolve 360-degree. So it will revolve and make a circular pattern. And I choose this section to revolve. So the axis of revolution will be this line right here. This line right here will be the axis of revolution. After I make my sketch 3D, I simply fillet all the edges. Also the inside edges. This is my seventh part, which is the seal. So this will be my rubber seal. Let's take a look at the sketch. First, I start with a simple sketch using a center point straight slot. I can simply make this shape. Okay, so the the diameter between the diameter of the circle right here is 78 millimeters. The distance between the two center of the circles with 63.5 millimeters. Using convert entities, I can simply repeat the inside pattern and make it 2.5 millimeters bigger than the original pattern. After that, I can simply use box extrude feature to make my sketch into a 3D object. So the depth or the width of for my rubber gasket will be 2.5 millimeters. And this is my last part for the gear pump. This is the rod for my secondary gear. So first let's take a look at the sketch. Starting with a simple circle with a diameter of 50 millimeters, and then using extruded boss feature, I make my sketch into a 3D object with a depth of 55.25 millimeters. After I done that, I fillet my rod, and I choose this surface and this surface to fillet like this. So it fillet these edges and also the back edges. Okay. After I done assemble all the parts, this will be how my gear pump looks. So I assemble all the parts except these screws right here and these two gear. These two gear I can find it from design library under toolbox. So under toolbox, I can use ISO, power transmission, and gears. So these two gears is a spare gears. With these spare gears at the top right here, this spare gears at the top right here is slightly bigger than the spare gears at the bottom. So it does have a difference in the size. And then the screws. The screws also the screws also I takes from the design library under bolt and screw. So it is so the screw is hex socket head ISO 4762, and I simply put the screw inside the hole. I can simply put the screw inside the hole, the hole that are available on the cover of my gear pump. So this is how it looks at the end. Oh, also I put a bearing at the inside of my gear pump. So the bearing is around the shaft for my gear pump, for my primary gear. So this is how my gear pump looks in after I done assemble it all. This this is the this is the top view for my gear pump. This is my side view of my gear pump. Front view, you can see how it rotates. And this is and let's just put it back into isometric view.